So we have a couple more exercises here to finish up our work on transformations. And these exercises are really important, exercise 4 and 5, because they illustrate the two skills we're really trying to develop. And number 4, we're trying to be able to look at formulas that may appear to be sort of complicated and realize that the graphs are not complicated, that they're just transformations of certain elementary functions, toolkit functions that we already know. In exercise 5, we're looking at graphs that should be very familiar in shape, and we're realizing that we can come up with the formulas without too much trouble just by applying what we know about transformations. So let's start with exercise 4. It's 3 parts, and here's the exercise written out by hand. And on part A, what I see is minus x plus 2 in parentheses squared. I realize right off the bat that this is a transformation of y equals x squared. And because I see the plus 2 inside parentheses, I realize that I should shift 2 units to the left. And the minus sign out in front is telling me that I should reflect through the x-axis. So let's see if we can get a graph for this. I'm going to start out with just a basic parabola. There's 3, 9, and negative 3, 9. You don't have to be this precise with point plotting, but having a graph grid helps. Shift 2 units to the left. Main thing is get the vertex shifted 2 units to the left, right? And then my points at 1 and negative 1, so that turnaround of the parabola is going to be there. I'm going to go up to that point here. This is going to shift 2 units over. And these guys will each shift 2 units over. Okay, so now I got an image shifted 2 units to the left. Now I got to reflect through the x-axis. This 0 point's going to stay the same. These 2 points, now the parabola's going to turn around that way. This point is on the y-axis 4 units up. It's going to be 4 units down. If you get really thrown by any of this, you can always plug in and calculate values. I actually, when I shift it over, instead of 3, 9, I have 1, 9. So now I'll have 1, 1, 2, 3, 4, 5, 6, 7, 8, negative 9. And then instead of negative 3, 9, I had negative 5, 9. So now at negative 5, I should have 3, 4, 5, 6, 7, 8, negative 9. So I'm being sort of picky here about points, but let's get our final graph in blue. Pretty good. And I think, notice that most important point here is to get down that negative 2, 0, to get the shape curving downward. So there's the blue is our transformed, our final form of that function, f of x equals minus x plus 2 squared. Pretty cool. And now let's do part B. G of x equals absolute value of x minus 2 plus 2. So we're going to work from just the absolute value of x graph, which is easy for me to remember in pencil. And we got a minus 2 inside, plus 2 outside. So working inside to outside, we have to shift 2 units to the right, that way, horizontally, and we also have to shift up 2 units. And what I like about what we know about transformations now is that there's no way this minus 2 and plus 2 cancel each other out, which I think a beginning algebra student might say, oh, don't they just cancel out? No, not at all. I guess I can go right to my final version here because I'm going to shift to the right 2, up 2. The point of the thing is going to end up here. And each one of these points is going to go over 2, up 2. This point's going to go over 2, up 2. And my graph is going to be here and here. It kind of overlaps. But what's crucial is this point right here is 2, 2, where the point on the absolute value is. So there's our final graph of B. And now let's draw a graph for part C here. Let's see. Now this is maybe a little bit trickier to think about. I am basing my drawing on what I know about the square root of x. I think you can see that. And it helps me to rewrite this as same function, h of x equals minus the square root of x plus 1 with the plus 5 on the end. So to change the order of those terms. So I have 3 operations going on here, working inside the square root to outside. First, I have to shift 1 unit, let's see, to the left, because I have a plus sign inside the square root box, so I have to go to the left horizontally. Next, working my way out, I'm going to reflect through the x-axis, and then I'm going to shift up by 5 units, right? Shift upward vertically. So the plus 1, the minus sign, and the plus 5 are 3 separate transformations. And let's start with my square root graph. 1, 2, 3, at 4, I'm 2 units up, 5, 6, 7, 8, 9. I'm 3 units up, so I'm just trying to draw the original square root. I got to shift to the left 1 unit. So all these points are just going to shift over 1. So there's my second graph shifted to the left. Then I got to reflect through the x-axis. And so now I'm coming down. I'm just that bottom half there. And finally, I got to shift up 5 units. So this starting point here is going to go up 1, 2, 3, 4, 5. But now I'm still the bottom half of this guy, right? So this, where I'm swooping down, is going to go up 1, 2, 3, 4, 5. And 1, 2, 3, 4. If you don't get points in exactly the right spots, it's not crucial. But we want this shape, this kind of overturned square root graph. And I think we kind of want to know that there's something important at this point. -1, what is that going to be? -1, 5, right? So let's draw in our final graph. So it starts at this point, crosses the y-axis 1 unit down, and just falls slowly to the left. Somewhere eventually it'll cross that x-axis. We don't have to get that in this picture. So there's that square root graph. I mean, it's related to that guy. That's what we started from. We transformed it into this position here.